Alright guys, welcome to Numbers. Thank you so much for the feedback you've given me on the previous 3 videos. In one of those videos, Sohail just mentioned that why not do a video on Chinese remainder. So let's do a video on Chinese remainder. Now what is Chinese remainder theorem? Let me explain this to you in a very lucid manner. First of all, starting with something like this, 70 by 6. Okay, now usually the trend in remainders is you can split the numerators but you can't split the denominators. Chinese remainder theorem says, however, you can split the denominator too. Okay, and then ultimately combine both these remainders and get the actual remainder. So let's try this with a small number, 70 by 6. All of us know that the remainder is 4 here, okay, but still we'll find out using Chinese remainder. So we split the denominators in 2 and 3 because 6 is 2 and 3. Okay, now I'll find the remainder here. The remainder here is 0. I'll find the remainder here, 70 by 3. Remainder is basically 7, which means 1. Okay, so I would say that when divide by 2 the remainder is 0, when divide by 3 the remainder is 1, which means the actual remainder, okay, right, AR is a multiple of 2 and a multiple of 3 plus 1. Okay, so you have to find out something that is a multiple of 2 as well as multiple of, I'm so sorry for this k is not the same across, so it can be something else plus 1. So multiple of 3 plus 1. Now which number will satisfy this? Okay, so you can always have 2k minus 3m is 1, so that you keep variables on one side. Now you have to think about it, which number is such that it's a multiple of 2 from which a multiple of 3 subtracted you get 1. So I have first pair as 4 and 3. Okay, so in that case k becomes 2 and m becomes 1. You can resubstitute m1 here or k2 here and you'll get the same answer. If you, for example, if you substitute m is 1 here, you get 3m plus 1 is 4 and k2 here is 2k is again 4. So the actual remainder is 4. Okay, a very lucid and a very simple way of doing this. Okay, the actual remainder is 4. So what you do is, I'll repeat this, you split the denominator into 2. Okay, 70 by 2, 70 by 3, and then you proceed in the way I've explained. Okay, now why do we need Chinese remainder? Because there are some problems. For example, let's say I have something like this, 3 raised to 100 divided by 77. Now 77 and 3 raised to 100. Now in this case I can actually say that the Euler number of people who know Euler's theorem, 77, the Euler number is 60. Alright, there's a shortcut to find this too. I'll explain that to you in some other video. Okay, so 60. Okay, so now we have 3 power 60 into 3 power 40 divided by 77. Again there's a mess because this is still a big number. Okay, 3 power 60 will be taken care of because of Euler's, the remainder will be 1. This is a big mess. Okay, so how do you resolve this? What you can do is you can use Chinese remainder theorem here, divide by 7 and divide by 11. Okay, so now we have two different problems altogether. Okay, so we have 100 by 7. Now 7 has 6 co-primes, which means it'll remove all the 6's till 16 6's, then 96, 3 raised to 4 by 7, and this will be the remainder 1. The only thing is 81 by 7, the remainder is 4. Alright, and talk about 11 co-primes, number of co-primes less than 11 to 11, 10. So I have remainder is 1. So we now arrive at a conclusion that when divided by 7 the remainder is 4, and when divided by 11 the remainder is 1. Alright, because 11 has 10 co-primes, straight away you will get 1 as the remainder. So you have to find a number such that a multiple of 11 minus a multiple of 7 is 3. I'm keeping it positive all the time so that it becomes easier. You have to find a multiple of 11 from which if you subtract a multiple of 7 you should get a 3. Okay, and if you notice you have k is 6, 66 and 63. Okay, so I have k is 6 and m on the other hand is 9. Okay, I can resubstitute this back here and this back here. Either way I'll get the same answer. So k is 6, you'll have 66 plus 1, 67, and 9 here again you have 63 plus 4, 67. So in either case you need not substitute both of them because anyway you'll have the same answer. So the answer to this problem is 67. Okay, so let's look at another example on the same. If you have 7 raised to 49 by 255, so what you can do here is obviously 255 is 15 into 17. So the number of co-primes would be 14 into 16. 16 here, 14 here, so that's 224, and the power is 2 less to reach 224. Okay, so what you do here is you split that into divide by 15, one problem, and divide by 17, the other one. Okay, so now let's solve these problems individually. So I have 7 raised to 49 by 15 as the first problem. Now 15 has 8 co-primes, so 7 power 8 raised to 6 is 48, and 7 left 15. This portion will give a remainder of 1 because of Euler's, and that the remainder is 7. And on the other hand I have 7 raised to 49 divided by 17. 17 has 16 co-primes, as 17 is the prime number. 7 power 16 power 3 into 7 over 17 will leave a remainder of 7. So in both cases the remainders are same, 7. Okay, it's actually a brilliant case, a very special case. I'll explain that to you how. Okay, so I need a number. The remainder that I need is a multiple of 15 plus 7, multiple of 15 plus 7. It is also multiple of 17 plus 7. Alright, 7 cancels, so I need a number which is a multiple of 15, which is also a multiple of 17. Now obviously 15 and 17 have nothing in common, so m has to be 17 and k has to be 15, alright, because only then they'll be equal, okay, because they don't have anything in common, alright. And then you can substitute m is equal to 17 in any in this one, and you get 15 into 17 plus 7, which is 255 plus 255 plus 7, which is nothing but 262, which means the remainder actually is 7, because 255 will divide itself out here, okay, so the remainder is 7. So a beautiful conclusion here. So I'll repeat this entire thing again. So first of all, 255 is 15, 17, I found remainders in each case, so the remainder of this is of this form. 7 cancels 7, 15m is 17k, so m and k are going to be reverses of each other, and 15, 17, 17, 15, alright, and then you can substitute m here or k here and you get the answer. The special case here, by the way, is if both of these are the same remainder, they will get cancelled, okay, so eventually you will arrive at that number, which means if both of them are the same remainder, that will become the answer directly, 7, alright, and I think that solves your queries on Chinese remainder, Sohail. Thank you very much for the request, and keep pouring in more requests. Hope you enjoy your cat journey. Hope you enjoy preparing with us. All the very best for you.